All right, Mr. Dresser here. Before we talk more about similar triangles, a quick coronavirus joke. It's appropriate. I was watching baseball the other day, major leagues, right? I was watching the Giants play, and I noticed it looked like it was really hot in the stadium. Like they're all sweating, and then I realized, it's because there's no fans. All right. Similar triangles. So again, similar triangles are the exact same shape, but are different sizes. We know the angles are congruent, but the sides are proportionate. So to solve these problems, we are going to use proportions. So we're going to find the missing length. We're given that triangle DEF is similar to triangle LMN. So I know the sides are definitely proportionate. And so now I'm going to find the side that's missing. And I know that this side, LM, corresponds to DE. So I know that they are going to go together. Oftentimes we can look at the picture and we know which ones go together. But if not, we can always use our similarity statement. I also know then that this 36 side down here, which is LN, will have to go with side DF. So I know that those are the corresponding sides. Now the way I set up the proportion, we actually have lots of options, which is what I really like about a lot of this geometry we're doing, is there's multiple ways we could solve this. So I'm going to show you one, and then I'll probably show you a couple of the others that work and give us the same answer. So the first thing I could do is I could do 70 over x. All right, I'm taking two sides that correspond, and I'm taking one side of one triangle over its corresponding side in the other. And then I could set that equal to, well, since I use 70 on top, I need to use the other side of this triangle on top as well. So I'm going to put 60 on top, and 60 corresponds with 36. So I've got my proportion, 70 over x equals 60 over 36. I can cross multiply. 60x equals 70 times 36. And oh my goodness, that's such a big number. I better grab my calculator. The one with batteries in it though. All right. So I've got 70 times 36, which is 2,520. And then to get x alone, divide by 60. And I get 2520 divided by 60, 42. X equals 42. Okay, so that was one way I could set it up. Now, I could also go backwards, right? Instead of 70 over x, I could do x over 70. And if I do x over 70, since I started with the bottom triangle, I'd have to then do 36 first over 60. Right? And when I cross multiply, I will get this exact same equation. I will get x equals 42. Now, one additional way you can do this, and I actually end up doing this a lot, is I can make a proportion out of the two sides from the same triangle. So I can do blue over green. I can do 70 over 60. So I guess I'll keep it color coordinated here. 70 over 60. And I need to make sure that I use the corresponding sides for my second one. So since I went blue over green, I will go blue over green. So x over 36. And now when I cross multiply, I still get 60x equals 2,520. That's the same thing I would get down here as well. 60x equals 2,520. So all three ways, and there's actually another way I could do it. I could also do green over blue, right? So there's multiple ways we can do it. But the bottom line is, as long as you're consistent with which parts you line up where, and you keep the corresponding parts in the same locations, it doesn't matter which way you set it up. You're going to get that x equals 42. I think for the sake of keeping it simple, I'll probably do a few of the problems just using one way to set it up. But maybe try a few others on your own and see if you still get the same answer and see if your idea would still work. Okay, so now we have triangle TUV is similar to triangle DCB. And I'm trying to find side DB, which I know will then have to go with side TV. So those are corresponding sides. And then I have side CD, which will have to go with UT. So UT is right here. And let's go ahead and do the corresponding pieces together. So I'm going to go ahead and do green over green. So 4 over 28. And then blue over blue. So X over 42. And then I can cross multiply. 28x equals 4 times 42, which I'm pretty sure I know, but I'm going to double check it just to make sure. There we go, 168. Divide both sides by 28. And x equals 6. Voila. Okay, this one, it might be kind of hard to tell when you look at it to know which sides go together, right? So I'm going to use my similarity statement again. If I decide to start with 9, which is side KT, I need to match that up with the corresponding side ST. So those two sides go together. So maybe I'll do 9 over 18. And then 5, right, that's the same triangle as 9, so I'm going to start with that on top, is going to go with the 2x minus 10. Once we set up our proportion, we can go ahead and solve. So now I can cross multiply. 5 times 18 is 90. And then I have to be careful right here because I need to do 9 times this whole quantity. I need to do 9 times 2x minus 10. So I like to put that in parentheses to remind myself that I need to distribute that 9 to both of those terms. So I end up getting 90 equals 18x minus 90. Add 90 to both sides. Divide by 18. And I get x equals 10. Nice. Now, this is one where you might look at it and just kind of use the idea of scale factor and do this problem without even doing all this work. I know to go from 9 to 18, what's my scale factor? It's 2, right? So if this is 5, what does this length have to be? Well, this length would have to be 10, right? To keep the scale factor of 2. So then I could do 2x minus 10 equals 10, and then just solve that equation, just using the idea of scale factor. Then I get 2x equals 20, x equals 10. So same answer that I got using the proportions. Again, if this didn't make sense, don't worry about it. As long as you can set up a proportion, you'll be able to solve these problems. But I do like to point out that there are some other ways using what we know about scale factor. All right, so I've got NM, which was 7, over SR, which is 7x. And so if that's what I do for my first fraction, how do I need to set up my second fraction? That's right, since we did 7 on top, I need to do 10 on top. And that'll be 10 over 30. Once we have that proportion set up, we can solve by cross multiplying. So 10 times 7x is 70x. 7 times 30 is 210. Divide both by 70. And x equals 3. Again, a shortcut might be, oh, 10 times 3 gives me 30. 7 times 3 gives me 21, so I know that 7x has to have a length of 21. Divide by 7, x equals 3. Not every problem will be as easy to find a shortcut like that. That's why proportions are kind of the one we want to use the most, because when in doubt, proportion will always work. All right, the next couple are very similar to some of the Khan Academy that we assigned for this week, which is the Solve Similar Triangles Advanced, right? Ooh, sounds advanced. And so in this triangle, I have the triangle ABC, all right, which is this smaller triangle. I know that it is similar to triangle ADE. So we've got this bigger triangle. Side note, the reason I know they're similar is they both have a 90-degree angle. All right, so that's an angle. And then we have reflexive property with an angle, which shows us that angle A of the green triangle is the same as angle A of the red triangle. So they have to be congruent angles. Therefore, we have angle, angle. That's how we know the triangles are similar. But when I go to set up my fraction, I notice that 2, side BC, goes with this side right here, side DE. So I know that 2 and x are corresponding parts. And then I also know that 6 is the base of this triangle, or AB, right, the first 2 letters. And that's going to go with AD of the big triangle. So AD is this section here, which was 6, plus this section here, which is 4. So I need to take the 6 and the 4 and add that together to get the entire length. Hey, segment addition, we did that in week 1. 6 plus 4 is 10. So now I have my proportion that I can go ahead and solve. If I cross multiply, I get 6x equals 20. Divide by 6. And I get x equals 20 over 6, which reduces to 10 thirds. Or if you do that as a decimal, that's 3.3333333 forever. All right. So sometimes our similar triangles are nested inside of each other like this. We can still do those problems. Another way you could actually approach this problem, and I'm going to go ahead and draw it out on here, is we could separate into 2 separate triangles. And so if I redraw this littler triangle, I know that side AB is x, and I know that side BC is 2. And then if I redraw my large triangle, I have side AD. How long is side AD? Well, it's not 2, it's not x, it's that whole thing. So this side is actually x plus 2. We need to add those 2 pieces together to get the full side length. But then I do know that side DE right here is 3. And so now if I kind of ignore this original figure, it might be easier to now see that x is corresponding to this side here, which is x plus 2. So I'm going to go ahead and write fraction x over x plus 2. And then I can take these vertical parts, or side BC, which will go with side DE. So I get 2 over 3. We've got our proportion. We can go ahead and solve. So I'm going to give you some time to go ahead and actually solve this and tell me what you get for x. Go ahead and pause if you need to. Actually, I pause it for you, so don't worry about that. All right, here we go. Cross multiply, that's 2 times the whole quantity of x plus 2 equals x times 3, which is 3x. Distribute. 2x plus 4 equals 3x. Get the x's to the same side. And I get 4 is my x. So x equals 4. Hope you did okay with that one. All right, I threw 2 more problems on here because they're good ones that you'll see on your quiz this week. Have to think a little bit harder on these. They're actually pretty similar to the 2 we just did as well. But I know that ABC, this smaller triangle here, is similar to the big triangle, ADE. And I noticed that this side of the little triangle goes with this side of the bigger triangle. And so I now need to find 2 corresponding sides, or 2 more pairs of corresponding sides. So in my littler triangle, I have this side here, which has a length of x. And I need to compare that with this whole side here, right? So from there to there, which is not just x, but it's also an additional 4 centimeters. So I'm going to do x plus 4. And now we can go ahead and cross multiply. 6x equals 3 times the whole quantity of x plus 4, which is 3x plus 12. Oop, that's 6x. Thank you, Mr. Dresser. Subtract 3x on both sides, and I get 3x equals 12. X equals. All right. Triangle ABC is similar to triangle ADE. So we've got the little triangle again. We've got the big triangle. And I noticed right off the bat that side BC is similar to side DE. So I'm going to make a proportion of 7 over x. And then in the smaller triangle, the other side I know is this 7 right here. And which side will that 7 go with? How long is its corresponding side? Well, the corresponding side is going to be, instead of AB, we're going to use AD. So that's this whole side right here. So I have 7, but I also have 5. So I'm going to add that together to get a full length of 12. Now I might look at this and realize, oh, that's the same number, so this has to be the same number as well. But if you didn't recognize that, you could go ahead and cross multiply, and you get 7x equals 84. Divide by 7, x equals 12. Ready to finish the rest of the Khan Academy about similarity. So if you haven't completed these yet, go do that now. It'll be good practice for you. These ones you'll determine if they are similar or not. And then on these ones where we're solving, you're going to take triangles that we know are similar and use proportions to solve.